start with Rolle's theorem. So a theorem is something we can assume to be true. You are going to have to kind of know what these theorems tell us. So Rolle's theorem requires a couple things. First of all, the function has to be continuous on the closed interval. So continuous, that means no breaks in the graph, so you're looking at like fractions with domain problems, those kinds of things. And the endpoints are part of that. Second of all, it has to be differentiable on the open interval. We already know that when we have breaks in the graph, that's usually a problem for our derivatives. What's another thing that can make it not differentiable? When is a function continuous but not differentiable? Can you think of an example? We looked at one yesterday. When there's a corner, so like an absolute value graph, it's continuous, but the derivative doesn't exist at that corner. The third requirement for Rolle's theorem is that the endpoints have to be equal. And it tells us if those three things are true, it's continuous on the closed interval, differentiable on the open interval, and the endpoints are the same, then somewhere between those endpoints, the function has to have a derivative of 0. So the next slide, I put some pictures to kind of justify that. You know, it is possible that maybe you just have a horizontal line. The endpoints are the same, it's continuous, differentiable. In this case, everywhere in that interval, the derivative is 0. Other cases, the only way to get the endpoints to be the same, at some point, if I'm going up, I have to switch and start going back down. And when I do that, I have a place where my derivative is 0. Or I could have multiple places. Maybe I go up and down and back up. So I have 2 places in this one where my derivative is 0. Or if you go down, you have to come back up. So does it seem believable to you guys that if those requirements are true, you would have a derivative of 0? And if the requirements are not true, it doesn't necessarily mean that there isn't a place where the derivative is 0, just that there doesn't have to be. Because we could certainly have a break in our graph or something like that if it wasn't continuous. I could prove this, but are you guys really interested in the proof? Or we're a little bit behind, so I was going to kind of skip it if that's okay. So, let's go to this example. If the position of a moving object at 2 different times is equal, what does Rolle's theorem tell us? Very basic question. Position. So let's assume, you know, we've looked at lots of position functions. They're usually polynomials. So is it continuous and differentiable if it's a polynomial? Yeah. So if the position at 2 different times is the same, if it starts and stops at the same place, what does that tell you somewhere? The derivative was 0. Or that means we know the derivative is velocity. So somewhere the velocity was equal to 0. And it could have been more than one place. All right, so let's actually work a problem where we have to apply it. So this is my function. And we're looking on the interval 0 to 1. Find a number c that satisfies the conclusions of Rolle's theorem. So if I'm asking you to do this and do Rolle's theorem, you do have to verify the conditions for me. Okay, if it helps you, you can rewrite it. What does a 1/2 power mean? What's a 3/2 power? Okay. So if I'm only putting in positive numbers between 0 and 1, can we do the square root of everything between 0 and 1? Yeah, can we do the derivative of this? Let's see, let's do the derivative real quick. So if we look at the original, that would be 1/2 x to the negative 1/2. x to the 1/2. Okay, if you need to check if this derivative exists, you could rewrite it. A negative 1/2 would be like a square root on the bottom. What is the only place where this does not exist? Okay. So did we agree this was continuous on the closed interval? 0 to 1. The original function, could you put in every number between 0 and 1? Yes. The derivative. So we did our derivative so we could look at it. What's the only place where the derivative doesn't exist? 0. But remember, it only has to be differentiable on the open interval. So it doesn't have to exist at 0. So the derivative exists everywhere else, so it meets that requirement. It's differentiable on the open interval 0 to 1. You don't necessarily have to provide me a lot of justification for why on these. The continuous, you're basically looking at the original function and is there anywhere it's not defined? The differentiable, basically, I would recommend just taking your derivative and looking, is there anywhere that's not defined? And then you have to mention those two things. What's the third requirement of Rolle's theorem? The endpoints have to be the same. So let's check that. If we put in 0 to the original function, so that's the square root of 0 minus the square root of 0 cubed, what do you get? If we put in a 1, square root of 1 minus the square root of 1 cubed, what do we get? So are the endpoints the same? Yes. So the requirements are all met, and we verified those. Now we get to actually do Rolle's theorem. What does Rolle's theorem tell us? Right, there is some number between 0 and 1 that makes this derivative 0. So let's find it. We already did the derivative, right? So no need to redo it. So if I wanted to rewrite this, let's just leave it like this for a second. So if I set my derivative equal to 0, cross multiply, 2 radical x times 3 radical x would be 6x equals 2. So x is 1/3. Is 1/3 between 0 and 1? So we just found the number that made Rolle's theorem true. So on these, I'm checking, did you mention all the conditions and verify them? And then did you find the number that made the derivative 0? Let's try a few more of those. If I look at this one, here's my function. Can we do Rolle's theorem here? If you need to, you're welcome to rewrite it just for purposes of deciding if it's continuous. A 2/3 power means what? Can you do the cube root of anything? Yeah, we can do positives or negatives. So it's continuous. It's defined everywhere. What's the second requirement? Differentiable. So let's check if it's differentiable. To do that, let's do the derivative and see. Derivative of 1 is 0 minus 2/3 comes down. Subtract 1 from the power, which is a negative 1/3. So if we think about what that means, a negative power puts it on the bottom. A 1/3 is a cube root. Where does that not exist? Can we do Rolle's theorem? Why? The other one could not exist at 0 and we still did it. It's in our interval. Is it 0 between -1 and 1? So there is a place in our interval where the derivative does not exist. So that means we can't do it. So this one is not differentiable at x equals 0. Since 0 is in the interval, we cannot use Rolle's theorem. So always make sure you are verifying those requirements. There are situations where it can't work, and at that point you just tell me it broke this rule, so I can't use it. Let's see if we can do Rolle's theorem on this one. Is this one continuous? Yes, it's a polynomial. Polynomials are continuous everywhere. You might even be able to answer the next question before we do the derivative. Is it differentiable? Yeah, anytime it's a polynomial, it's automatically continuous and differentiable. And that was something we had early on this year. So, you say it's continuous on the closed interval, -2 to 2, because polynomials are continuous everywhere. It's differentiable on the open interval, -2 to 2, because polynomials are differentiable everywhere. And you could certainly do the derivative and verify that. We're going to do it in a minute anyway. What's the third requirement? Okay, so we have to put in both a -2 and a +2 and see what we get. So if I put in -2, is -6. We put in a +8 minus 4 minus 8. So the endpoints match. That's all my criteria. Since we do that, we can do Rolle's theorem. Rolle's theorem tells us that somewhere the derivative is 0. So we do our derivative. Set it equal to 0. What would we do to find that? Try Box method. Do we have anything that multiplies to -12 and adds to -2? So what do we have to do? Should it be plus or minus the square root of b squared minus 4ac over 2a. So we get 4 plus. So it's the derivative equals 0. Plus 48 52, we can break that down, right? 4 13 and then we could divide everything by 2. So we get 1 plus or minus the square root of 13 over 2. We should verify that these are both in the interval because it's possible. Rolle's theorem said that there's at least one in the interval. There could be more than one, or we might have just found 2 values and only one of them is in the interval we wanted, so you should always double check that. To verify it, you could just put it in your calculator and get the decimal. 1 plus the square root of 13 divided by 3, 1 minus the square root of 13 divided by 3. Both of those do fall between -2 and 2. So those were the two numbers we were looking for. Any questions on that? Second piece is the mean value theorem, which is actually just an extension of Rolle's theorem, or a more generic case. So the requirements start out the same. It's continuous and differentiable, same as Rolle's theorem. Rolle's theorem says that if the endpoints are the same, then somewhere the derivative is 0, right? If the endpoints are the same, what's the slope between those? 0. And so the derivative was 0. Mean value theorem says if it's continuous and differentiable, then there is a point where the derivative equals the slope between the endpoints. So Rolle's theorem is the case where the slope between them is 0, so somewhere the derivative equals 0. Mean value theorem says it actually works for any slope. If you find the slope between your two endpoints, somewhere the derivative is going to equal that. Another way to think about it, derivative is like a velocity, right? So if you take a trip and your average speed is 70 miles per hour, is there any way that your average could have been 70 without you ever hitting 70 miles per hour while you were driving? No, you had to at some point, at least one time, probably multiple times on your trip, have driven exactly 70 miles per hour. That's the only way it can work. That's what this is saying. Okay, if you had the average between the endpoints, at some time you hit that speed while you were driving. I have a few pictures just kind of illustrating that. You know, if we have two endpoints, you can find the slope between them. Somewhere the tangent line would be parallel to that. All right, I really apologize. I was really trying to be lazy and screenshot things, and it didn't work out so well. But apparently I didn't care enough to redo it. So here it is. I want to find the point on the interval 2 to 4 where this would be true. Okay, so if we look between 2, so here's when x is 2, here's when x is 4. Okay, you guys might even have a slight advantage because you have actual paper and you could write, even use a ruler. If we are trying to find the tangent line between those. Okay, so if we look at the line between those. Okay, something like this. Can we kind of estimate a place where the derivative would have the same slope? So when we would have a tangent line that is parallel to this. If you think about that. Okay, it would have to be over here somewhere, right? So do we agree about maybe right there? So the x value at that point is 3. So at about x equals 3, the tangent line would have the same slope as the slope between those points. X value is between 2 and 4, so it works. All right, let's look at this one. If I wanted to go between -1 and +3, so -1 is this point on my graph, +3. So if we looked at the slope of the line connecting those, and I need to find a place when the tangent line would be parallel to that. Well, tangent line, remember, is like touching your graph and bouncing off of it, so it couldn't be over here. You can also look, it would have to be increasing because the slope is positive. So it would have to be over here somewhere. So we're looking when that could be a possible point. So hitting the edge of the curve and bouncing off, so it looks like it would have to be about here, at about 1. And 1 is between -1 and 3, so we found a point where that happened. Okay, Not great. I know the pictures aren't high quality, but just trying to give you a visual for what this means. What about this one? What's wrong with this one? It has a corner. You know, I could look at the tangent line between 1 and 4, but there is nowhere where the derivative would have the same tangent line. And the reason, we know there's a corner and there's no derivative there. So there are no tangent lines on this one because of that corner. If we look from 0 to 2, here's 0, here's 2, that's a horizontal line. Is there anywhere where I have a horizontal tangent line? No. Why? There's a break in the graph. So this is just showing you if those requirements for being continuous and differentiable aren't met, then it doesn't work. We're doing really well on time. Let's go ahead and do the next one. So if I want to find a value that would make the mean value theorem work for f of x equals x cubed minus x on the interval 0 to 2. I will allow you, x cubed minus x is what? What kind of function is that? It's a polynomial. And we know that polynomials are continuous and differentiable everywhere. So if you want to just state it's a polynomial, so continuous and differentiable, that's fine with me. Now, if it's not a polynomial, I do expect you to verify that it's continuous on the closed interval, differentiable on the open. But polynomials, since it works everywhere and we know that, you could just state that. So then mean value theorem says somewhere the derivative equals the slope between the endpoints. So we need the slope between the endpoints. So we have to think, if I put in 0, what do we get out? If we put in 2, what do we get out? 8 minus 2, which is 6. So slope, these are like 2 ordered pairs. y2 minus y1 over x2 minus x1. And we get 3. So that means somewhere the derivative is 3. So do our derivative and set it equal to 3. Square root plus or minus. So we would have 2 over the square root of 3, or 2 radical 3 over 3. Are both of those in the interval? No, we were wanting the number between 0 and 2, so we need the positive one. Now, that doesn't mean the other one doesn't work. The derivative is also 3 at negative 2 radical 3 over 3. But I only asked you to find the values between 0 and 2. Sorry, I'm really trying to debate what I want.